In the distant pages of Earth's history, ancient plains stretched beneath a pale Mesozoic sky. Among the giants of this world, none are more iconic than the Triceratops. And yet, another horned giant once wandered these same lands, the Torosaurus. Today, their fossils act like postcards from a vanished world. Weathered bones, brushed free from ancient rock, guide us back across millions of years. Each clue helps scientists rebuild the lives of these massive creatures. Their world was a land of great distances, where herds moved slowly under endless skies. Powerful, deliberate, unmistakable. And yet, the Torosaurus carries a different story in its bones. Both lived in what is now Western North America during the final moments of the Cretaceous. But one question echoes through paleontology. Are Triceratops and Torosaurus truly separate species, or simply two chapters of the same ancient life? Today, we open the postcard and step back into their world.
Meet Triceratops, one of the most familiar horned dinosaurs of the late Cretaceous, walking the plains of ancient North America. Adults measured roughly 8 to 9 meters long and weighed on the order of 6 to 12 tons, enormous for a plant eater. Its body was massive and low to the ground, with powerful limbs built to support heavy weight and slow, steady movement. The 3 horns, 2 above the eyes and 1 on the nose, combined with a strong beak to shape and process vegetation. The beak allowed Triceratops to clip tough plant material, cycads, tough ferns, and woody stems before feeding them to its grinding teeth. Behind the beak sat dental batteries, hundreds of tightly packed teeth that wore down and were replaced, enabling powerful grinding and shearing of fibrous plants. Massive neck and shoulder muscles supported the head and horns, essential whether for feeding or defense. The broad, bony frill behind the skull served multiple proposed roles: protection, species recognition, and visual display. Many scientists believe the frill was a display structure, colorful, visible from a distance, used to communicate or attract mates. The frill also provided a bony shield for the neck, an effective barrier against bites from large carnivores. Field and tooth wear evidence indicate a diet of tough, low-growing vegetation, cycads, ferns, and woody shoots suited to its powerful jaws. Like many giant herbivores, it likely relied on a large gut for fermenting and extracting nutrients from fibrous plants. Did Triceratops live in herds? The evidence is mixed. Some ceratopsians show bone beds, suggesting group living. But Triceratops may have ranged from solitary to small family groups. A few aggregated bone sites hint at social behavior or mass mortality events, but interpreting these sites remains complex. Juveniles had different proportions. Horns and frills developed as animals matured, an important clue for understanding species identity and social signaling. Direct Triceratops nests have not yet been found, but related horned dinosaurs nested in shallow scrapes. It's likely Triceratops was an egg layer and may have nested in open ground. Parental care patterns are uncertain. Some evidence from other herbivores suggests adults may have protected or guided their young, but clear proof for Triceratops is limited. From field discovery to museum halls, Triceratops remains a bridge between the distant past and our modern curiosity, a living postcard from an age of giants.
In a drier, more open landscape, another giant herbivore moves with quiet purpose, the Torosaurus. Slightly shorter and lighter than Triceratops, Torosaurus reached up to 9 meters, weighing as much as 8 tons. Its stride was measured and calm, a giant adapted to roam broad riverbanks and open plains. With the largest skull of any land animal ever known, Torosaurus carried a structure both colossal and surprisingly light. The signature openings in the frill reduced weight, allowing Torosaurus to support a head nearly 3 meters long. The frill likely served as a visual signal, a canvas for communication, ritual, and recognition. Some scientists propose that the frill acted as a thermal window, radiating excess heat into the open air. Torosaurus fed on tough plants along river corridors, shrubs, ferns, and woody stems suited to its powerful beak. Like its relatives, it possessed layered dental batteries capable of slicing and pulverizing dense vegetation. Evidence suggests Torosaurus may have lived in sizable groups, finding safety and strength in numbers. Within these groups, frill movements and body posture likely formed a silent language. This giant preferred to avoid confrontation, using size and display to ward off predators. Only when pressed would it stand its ground. Most encounters ended in mutual retreat. Torosaurus lived where water shaped the land, in vast floodplains that alternated between abundance and drought. Rivers were essential to its life, drawing herds to drink, feed, and cool their massive bodies. Young Torosaurus looked markedly different, their frills growing and transforming as they matured. As they aged, their skulls evolved into complex structures, a hallmark of ceratopsian development. Though no Torosaurus nest has been found, its relatives laid eggs in open, shallow scrapes. Their migrations across open ground shaped the ecology of their environment. Today, its enormous skull stands as one of the most spectacular fossils in paleontology, a window into a world long vanished.
Triceratops measured between 8 and 9 meters long, compact, muscular, and built like a living fortress. Torosaurus reached roughly the same length, sometimes up to 9 meters, but with a noticeably slimmer, more elongated body. Triceratops weighed a massive 6 to 12 tons, one of the heaviest horned dinosaurs ever discovered. Torosaurus was lighter, estimated between 5 and 8 tons, due to its thinner frill and more streamlined build. Triceratops possessed one of the thickest skull shields in the dinosaur world, a massive bony wall capable of absorbing tremendous impact. Torosaurus, in contrast, had a thinner frill with large openings, sacrificing thickness for size and display. Triceratops' horns carried thick brow horns built for forward thrusts, perfect for charging or locking with rivals. Torosaurus horns were longer but slimmer, offering reach rather than raw striking force. The frill of Triceratops was shorter, compact, and heavily reinforced. Torosaurus possessed the longest frill ever recorded, stretching almost 2.5 meters. Triceratops had a completely solid frill, maximizing protection. Torosaurus displayed large openings in its frill, reducing weight and likely regulating body heat. In a direct clash, Triceratops's reinforced skull handled impact with unmatched stability. Torosaurus could deflect force, but not absorb it with the same power. Triceratops had a shorter, denser neck designed to support heavy horns in vigorous combat. Torosaurus featured a longer, more flexible neck, giving it a wider range of motion. Triceratops relied on a direct, confrontational style of defense. Torosaurus preferred visual intimidation and avoidance over direct conflict. Triceratops is believed to have been more aggressive and territorial. Torosaurus likely displayed a more peaceful temperament, reacting only when threatened. Triceratops moved with deliberate, heavy steps, stable but not highly agile. Torosaurus, being lighter, showed better agility in open floodplains. Triceratops thrived in humid forests and coastal ecosystems rich in tough vegetation. Torosaurus lived in drier floodplains where wide open spaces shaped its defensive behavior. In the end, neither species surpasses the other. Their strengths are shaped by different environments, different needs, and different evolutionary paths. Two giants, each successful in its own way.
The debate begins with two scientific camps, each convinced they've unlocked the truth. One argues for two separate species. The other claims they're simply different chapters of the same life story. To understand the mystery, scientists first followed the fossils. The map reveals where each skull was unearthed, and the puzzle pieces begin to fall into place. One theory suggests the frill simply changes shape with age, starting small, then stretching and reshaping dramatically as the animal matures. To test this, researchers scanned the bones layer by layer, searching for signs of growth, new tissue, remodeled edges, and patterns hidden deep inside the fossil. If both skulls belong to the same species at different ages, their growth lines should match, but the details don't always agree. Supporters of the single species idea propose a growth sequence. Young individuals growing into larger forms with reshaped frills and new openings. But critics fire back. The large openings in the frill aren't signs of age. They're structural features that don't simply appear as the animal grows. And so, the debate remains unresolved. Two skulls, two interpretations, and a mystery that still challenges paleontologists today. As the sun sinks behind the world they once ruled, one titan emerges from the dying light. From the other side of the fading day, another shape approaches, ancient and resolute. In this moment, the world seems to pause, framing them not as rivals, but as echoes of an age about to vanish. Horns that once shattered branches and warned off predators of impossible size. A frill like a living canvas, carrying heat, color, age, and meaning. And beneath their feet, the water mirrors their forms. Two destinies, two designs, one prehistoric story. Long after muscle and breath were gone, their bones became the storytellers. Their world, once vibrant and whole, faded quietly into the stone. Then came the fire that no creature could fight, a single moment rewriting life on Earth. In the end, no victor walked away, only silence remained.
It began not with fire, but with ash, a quiet veil drifting over a world unaware of what was coming. Soon, the great herds moved in panic. Even giants felt fear when the earth itself began to tremble. The forests that sheltered them for millions of years toppled as if made of paper. Smoke washed over the land, blotting out the sun and turning day into a long, cold night. When the plants died, everything else followed. One by one, the pillars of life collapsed. Both titans, once symbols of strength and endurance, stood powerless against a world that could no longer sustain them. In the silence that followed, the land embraced them, pressing their stories into stone, where they would sleep for 66 million years.